Let's talk mind control in nature, or more specifically, let's talk about Cordyceps fungi and all those wonderful zombie fungi, and how on earth that could relate to the orc creatures we have in Grounded 2. Hello there everybody, and welcome back to another episode of An Ecologist Plays. We talk about nature while playing games. My name is Will, I'm an ecologist by training, and we are back in Grounded 2, where we are... Well, today we are climbing the hedge up there, and we are going to be looking for some orc creatures up there, and who knows what else we find. Now, of course, I could try to finish the game, or well, finish the version we have thus far, the early access we have thus far. However, I don't foresee myself finishing and wrapping up and fighting the mysterious stranger today. I don't think I have the time to record that now, so I will leave that for another time. But for now, we are heading into the hedge here, so we should be able to just climb some branches and find some lovely little orc-controlled creatures up there. Of course, we've got some spiderlings coming to attack us. These, of course, are not orc-controlled. They're just functioning as normal. But the orc-controlled creatures, well, they will function very similar to those insects that are controlled by the so-called zombie fungus. Now, of course, zombie fungus, those will be the Cordyceps or the Cordyceps, those types of fungi. And they basically control the insects, or the invertebrates actually, that they parasitize. And we'll talk about why that is in a moment. But do note that they are very, very host specific. They generally don't attack like indiscriminately. They generally go for specific species. And very often their names, their scientific names, will actually give you an indication of what they attack. For example, there is an Cordyceps Camputini, something, floridensis, something along those lines, because it only attacks the Campanotus floridensis species, or Floridia species. So they're very, 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 very host specific. Now, I have made the Black Fang Great Bow, and you know, it would be a terrible shame to craft that and not use it. And well, there is a lovely little orc-controlled butterfly up there, and wow, we can do quite a bit of damage to it. And now it's dead. Well, that works. Okay, so this was an orc-controlled blue butterfly. In other words, it was a normal old blue butterfly. And now we just need to get our arrows back. And that butterfly was somehow controlled by the mysterious stranger. And the question is, how on earth can that be? But I do believe it is very similar to how the Cordyceps and other so-called entomopathogenic species of fungi actually affect their hosts. So entomopathogenic, pathogenic referring to causing some kind of disease or some kind of affliction, entomo referring to insects, so it causes some kind of affliction within insects, or actually generally in invertebrates, not necessarily only insects. It can also be in arachnids. So that I have, for example, found a harvestman that was also affected by an entomopathogenic fungus. So not the actual Cordyceps or Cordyceps, but by a similar species. Now, as we head up here, I suspect we should find, that's just a normal orb weaver, but we could expect to find some more orc creatures up here. The reason being that very often especially ones that are actually controlled by Cordyceps or similar entomopathogenic fungi, they actually head up. They head to higher areas. So the reason for this is to actually disperse the spores. But we will talk about that in a moment. I'm just going to, open up the path here by stabbing this little caterpillar. And then we're just going to go take on this normal orb weaver up here as well, which is just fast asleep at the moment. Or was asleep. Okay, there we go. I think everybody has been taken care of. Although, I do hear another butterfly, and I assume that is another orc blue butterfly. Okay, so we just have to keep our eyes open for that. Now, let's get back to Cordyceps and the so-called zombie fungi. Because, well, there are actually quite a few of those so-called zombie fungi that afflict invertebrates. And this is not something new. There are fossils of some kind of Cordyceps fungus attacking an ant. Well, actually not necessarily, not directly visible, the Cordyceps and the ant, but you could see the death grips that the ants had on leaves in the messel pits in Germany. So that was after the extinction of the non-avian dinosaurs. At some point then, those Cordyceps fungi affected some kind of ant, and the ants then bit into a leaf, and they bit into the veins of the leaf. And that is actually something we do see very often with these entomopathogenic fungi. They get the invertebrate that they affect, or that they afflict, to actually bite down onto something, onto some kind of surface. Oh wow, there's a whole bunch of Orc Weavers Juniors coming along here. Let's just, show them who's boss here. Now, I'm just kind of running around at the moment, attacking whatever I can find and whatever seems to be attacking us. With very little rhyme or reason, I'm heading up. That is the thing. Now, I say very little rhyme or reason, and actually at this point in time, I'm sounding very much like an invertebrate affected by some kind of Cordyceps fungus. And that's where it's, to me at least, so amazing. Those Camponotus, those harvester ants that are affected by the Cordyceps fungus, those Camponotus ants, their antennae seem to be permanently bent in an L shape. Whereas normally, ants will move the antennae around as they use it to communicate with other ants, but not the ones afflicted with the... oh, there we go, there's a little chest down there. I think I know what's in there. But not the ones that are affected by the Cordyceps fungi. Those ones have their antennae permanently bent in an L shape, usually towards the end of the infection, just before they die. And you know what? The reason for that is actually amazing. Now, normally ants, of course, there we go, that is the bushwhacker. I figure that is what we have here. Okay, we don't need it, so we're just going to drop it in our buggy here. A lot of these things we don't need. We're just going to drop in our buggy. All right, all good. Now, normally the ants, as I've mentioned, they communicate with each other by tapping the antennae. And it's very important for them to be in communication with other members of their species. But if you have your antennae bent in an L shape, you can't actually communicate with the other ants by tapping. And that results in those Camponotus ants actually wandering off, kind of appearing lost, but not necessarily really lost. But the fungus wants these ants to wander off and not stay with the rest of the ants, because if those ants realize that something is up with this ant, that it is infected by the fungus, then those ants will actually carry the infected ant away, far away from the nest. But the fungus wants the ant to stay relatively close to the nest so that when it disperses its spores, it actually has a good chance of infecting other Camponotus ants. So it doesn't want to be too far away from the other ants. So it forces the antennae of the ant into an L shape. That results in the ant wandering off, kind of seeming lost, and eventually it drives that ant to bite onto a surface, usually a leaf surface, and there it eventually dies. It results in the muscles in the mandibles degrading, no longer being able to open or close, and then it eventually results in the death of that infected ant. And then from that dead ant, a fruiting body would actually emerge, and then spores would be dispersed from it. It really is amazing. It drives the ant to go away from its colony members. It gets it to go somewhere higher, and we'll get to that in a moment. It gets it to climb somewhere higher, and then it gets it to grip fast onto a leaf or some kind of surface, and then there it dies. Okay, so we've got some Orc bombardier beetles here, and you know what? They are showing what insects or invertebrates infected with the Cordyceps, for example, will very often do. They go somewhere high. In fact, it's not only those affected by Cordyceps, it's also those affected by other fungi. For example, the green-banded broodsac, which is a type of flatworm that affects snails. In Dutch, it is known as the oogsteel slakkenworm, meaning eye stalk of snail worm. So it is a flatworm. It's not like an earthworm though, but it isn't a flatworm. And what it does is it hijacks the eye stalks of snails, a specific species of snail to be precise. And it has its brood sac, basically from where it will disperse. It has those in the eye stalks of these snails, and it pulsates. It's this green and white banded floppy, round, squishy thing that pulsates in the eye stalk of the snail, and it draws the attention of birds, and the birds then eat it, and it gets to complete its life cycle in the birds. But it will only be able to do that if it is actually spotted by the birds and then eaten. So at night it doesn't do anything. At night it doesn't pulsate, because birds generally aren't active at night. At least the ones that will eat the broodsac are not active at night, so they don't pulsate, they don't waste energy then. But during the daytime, they get the snails to go somewhere conspicuous, somewhere out in the open, like these bombardier beetles, these Orc bombardier beetles are doing. And then it will pulsate. It will rhythmically contract the brood sacs in the eye stalks of the snail, and that will then result in the birds, being drawn to the brood sac, and the birds then eating the brood sac of that green-banded brood sac flatworm, which is quite cool. The scientific name of that is Leucochloridium paradoxum. Paradoxum, kind of paradoxical, that it wants to be eaten to complete its life cycle, and leuco referring to white, chloridium green. So the white and green paradoxic creature, which I think is a very cool scientific name. Anyway, these bombardier beetles, they're kind of doing something similar. They want to be seen, they're out in the open. Maybe not perhaps to be eaten, but maybe it is something very similar to what we have with the zombie fungi, with those Cordyceps, where they want the infected creature to go a little bit above the forest floor, and if they can kill them here and sprout a little fungus, a little mushroom fruiting body from its head, then it's a nice area for wind to actually disperse the spores quite nicely. Better chance of successfully dispersing the spores up here than down there in the muck down there. Okay, so it wants to be out in the open so that the spores can be dispersed quite nicely. I just realized now, and I forgot about it earlier, I mean, look at those eyes of the bombardier beetles here, of the oak bombardier beetles. They are showing symptoms. They look like hypnotized. Well, that's actually what the green-banded broodsack also would look like. It's just white and green rather than black and bluish in color like we have here, that they are pulsating. So that is really, really quite cool. All right, now we are going to actually get ready to take out one of these bombardiers. Oh, and I'm just going down. Okay, well, of course that happened. And now I don't know how I got up there in the first place. I think it's this way around. Right, and I suspect Antilda is going to kind of suffer because of our absence. Yeah, there we go. Okay, so she's basically dead. We're just going to avoid that. And we're just going to, again, not be caught by that blast. And you know what? We're actually going to do that. Oh, actually be caught by that blast. Okay, maybe we can shoot that one. If we can just get rid of the one, that will be very nice. I must say, this great bow is very, very pleasant. And the last shot, I think. There we go, okay. Let's just get Antilda back up. But yeah, here we go. The reason why we were up here, to get rid of this orc transmission device. Okay, so that one is hacked. And now there are some orc soldiers by the fire pit still we need to take out. Honestly, I didn't even know we had to go there. Alright. We'll do that in daytime. We're just going to head home first. Somewhere in that direction. But while we are making our way over there, let's quickly talk about Cordyceps, because there are a few things that I want to quickly chat about that. It's not always bad. Okay, so first of all, Cordyceps, it does attack. Very often, the more abundant a certain animal is, the more likely it is to actually be attacked by its corresponding Cordyceps or Cordyceps-like fungus. It's entomopathogenic fungus. Okay, so the more likely it is to actually be kept under control by those entomopathogenic fungus, and the less likely it is that it will outcompete other invertebrates or other species in the area. So it's good. In terms of keeping the ecosystem functional, it is good. Oh, and yeah, we just unlocked the moon buggy again. I wish I remember how I accidentally did that now, but here we go. We've got the moon buggy again. Whee! It's fantastic. Alright, we are going to sleep though. And now that we have slept, unfortunately, no more moon buggy. Oh, that's sad. Alright, but let's head on over to the fire pit to have a look at those orc creatures over there. And on the way, I'll chat a little bit more about the entomopathogenic fungi, such as Cordyceps. Because recently, in the past year, they have found that there's actually a stink bug that is in Japan that uses Cordyceps and other fungi to protect their eggs against parasitoid wasps. So parasitoid meaning that it's a species that parasitizes another creature so that their young can actually be raised in the body of this host. So think of, for example, tarantula spiders being parasitized by parasitoid wasps, that, like the tarantula hawk, that lay their eggs in the tarantula, and then the maggots of that wasp will hatch and they will feed on the tarantula while it is still alive, eventually killing it, consuming it entirely, and then those little new wasps emerge from the carcass of the tarantula that they have been feeding on. Now those are parasitoid wasps. Now the stink bugs, of course, will also have a wasp species, or more than one wasp species, that would actually parasitize them. And obviously they don't want that. So it turns out that what they will do is they will actually have, as we're just taking on a normal bombardier beetle here, It's probably going to explode now. There we go. No. Until stop attacking everything in sight. And so what those stink bugs will have is on... And I did see something glisten at the back here, so we may as well actually go and dig this up quickly. Somewhere around here. There we go. Right there. So what those stink bugs have is the adult females, which the males don't have, actually. The adult females will have a special pouch-like structure on their hind legs. And in that pouch, they actually have this fungus living there, a bunch of fungi living there. And when they lay their eggs, hyphae, or the fungal threads of the fungus they actually have growing in that pouch, will grow over the eggs that they lay, and in the process then that protects the eggs against the parasitoid wasps and actually really prevents them, quite amazingly prevents them from being parasitized by those wasps. So that's a very nice defense mechanism, if somewhat strange for the fact that Cordyceps is one of the fungi that they will actually utilize in that cocktail of fungal threads, fungal hyphae that they use. Alright, apparently we have to head over here, so let's actually head down here, I guess. Ah, okay, apparently we need to head in here. Yeah, this is not ominous at all. Oh, there we go. A whole bunch of orc creatures. Okay, we'll get back here in a moment. Okay, I do see our other objective is way over there. That, I think, leads to our final area, which we are not going to do in this episode. Alright, so let's just quickly talk about the life cycle of the Cordyceps, as we actually, you know what, we are going to head down here and have a look at what we find over here. Hello there! We are probably going to be out of our depth here. Oh, there we go. Okay, so I am dead indeed. You know what, that is perfectly fine. Oh, look, we are at this space. Okay. You know what, I don't think the mantis actually spawns at these flowers anymore, or they haven't... It hasn't spawned in a very, very long time for me, so I suspect it has actually been taken away. This is no longer a spawn point. Maybe I'm wrong, Do tell me if I'm wrong in the comments below. Anyway, let's go through the life cycle of a Cordyceps, because it starts with a little spore. A little microscopic little, well, basically like a seed of a fungus, but not a seed. Okay, a spore. It then comes into contact with some kind of invertebrate, some kind of cold-blooded creature in particular. So it won't affect us as humans, unlike what The Last of Us will, you know, have you believe. It won't affect us. What happens then is it gets into the body of the invertebrate. And here it does a few things. One thing it does is it affects some muscles of the, let's say for example an ant. If the Cordyceps is affecting a Camponotus ant, for example, what will happen is that it first results in the ant experiencing muscle spasms, which then knocks it out of the canopy of the tree where it was. Once that happens, it is on the forest floor, and now the fungus causes the ant to climb higher up. It wants to be above the forest floor so that the spores can disperse more easily, but it wants to be relatively close to the forest floor where it's nice and humid. It wants the perfect environment for its little spores to establish successfully. That is what it really, really wants. So we're just going to, again, we're going to this time try not to die. And we already did again. Oh, lovely. I don't think we're going to make this. You know what, that's fine. I think I need to do it with a shield, and I can't do it with a shield while we are underground and it's dark, and I want to actually show you guys what's happening. So I'm just going to go there later on my own. I will go and get my stuff. Alright. But talking about what happens with the ant then, the fungus wants the ant to be at the right humidity, the right temperature, the right light, the right everything for its spores to actually be able to infect other ants, for example, or other invertebrates. So it brings it down from the canopy where it's not humid enough, closer to the ground level where it is more humid, but then it wants it to climb higher up again so that it can have a good chance of dispersing the spores. And the way it does that is by making the ant, for example, or the snail in the case of the green-banded broodsack, making it crave sunlight or a little bit more light. There are also some weird things. For example, if you're looking at toxoplasmosis, which is another parasite that affects, for example, rats and can affect cats as well and us as humans. I think about a third of us as humans are actually infected with toxoplasmosis, which is dangerous if you are pregnant, for example. But the way it works is that it infects a rodent and it makes that rodent extraordinarily attracted to the smell of cat urine, where usually it would avoid cat urine or the smell of cats or cats overall. Now it is attracted to it. And obviously that is not a good idea for the rat. So it's attracted to its predator, and then the predator, the cat in that case, then eats the rat, and the cat is then infected with toxoplasmosis, which then can easily get transferred to us as humans when we come into contact with feces of the cats and then ingest that. Not like eating the cat poop, but not washing your hands after you come into contact, knowingly or unknowingly coming into contact with cat feces, and then, well, toxoplasmosis gets you. But generally we aren't symptomatic, so obviously we aren't drawn to cats more than we already are, as if it would be possible for some of us to be attracted to cats even more. Anyway, now the zombie fungus gets the host, the ant, for example, or in some cases the flies, to actually bite down onto a surface, to attach itself, because it does not want its host to now become dislodged from where it actually is. It wants the host to stay there where it actually is. It wants it to remain at the right height or the right place for the spores to infect another host, for example. So in the case of ants, they will bite down with their mandibles onto a leaf, for example, or onto a twig. And in the case of fruit flies, they very often touch their sucker onto a surface, and then the fungus actually kind of secretes a sticky substance that then binds to the surface. And that will then keep them in place, so that the fruiting body can then emerge from that cadaver of the host, and then spread the spores all over the place. So in essence, when it comes to the favorite queen song of the Cordyceps fungi, it's basically we will spread spores. Dun-dun-dun. And there we go. Haha. Hello there, Spooter Man. My poor little buggy is just kind of taking a quick nap here, a little bit dizzy. Anyway, so what I suspect is happening with the orc creatures is that the mysterious stranger is tapping into their nervous system as well. Very similar to how the Cordyceps will do it. They have tapped into the nervous system of the ants and the other creatures that they have taken over, and they are making them crave certain conditions, getting them to go to certain areas to protect it against certain things. And in this case, I think it's also making them very, very aggressive, which is something that you also see in rabies, for example, where that virus, that lysovirus, makes the host very, very aggressive so that it can bite other creatures, and the lysovirus can then move over to the other host or be transmitted to another host. So I think it is kind of a combination of that, makes it very hostile and also makes the host go where they want them to go. Now, interesting also, I think that the orc creatures, like let's say for example an orc cockroach, is aggressive towards the non-orc cockroaches, which kind of makes sense because, well, if you have an ant that is infected with the Cordyceps, the other ants in the colony will become very, very aggressive towards it. They will notice that something is wrong and they will actually attack it and then kill it and take it away before the fungus has a chance to kill the host and sprout a fungal fruiting body from the head of that creature. So it really does make sense. I mean, they would be very, very aggressive. And in this case, I do think that they do attack, the non-orc creatures do attack the orc creatures. Again, maybe wrong with that, but I'm pretty sure I have seen that happen in the previous episode, or maybe the episode before that, I believe it was. Anyway, there is an amazing article on the mechanisms of how the fungi actually control their hosts. I'll link it in the little description below the video here. I also have it on my Discord channel, so if you want to read that, follow the link down there or join the Discord and you can find it there as well. But you know what, I think that is actually where we are going to be calling it a day, everybody. So thank you very much for joining me on a little adventure here. I have now more or less done what I wanted to do, for now at least, in Grounded 2. I will be carrying on with Grounded after the next update, I think, when we have 2 new creatures to talk about as well, at least 2 new creatures to talk about. So I will be back in Grounded then, but for now I am going to call it a day. And then next week we're actually going to be chatting a bit about Nightingale, because, well, some of you may have gotten that on the Epic Games Store recently where it was free. I definitely did. And I have been having a blast. Oh, that is the mantis. And I have been having a blast in that game. And let's chat a bit about the ecology of that game next time. And of course, as always, if you enjoyed the video, please do give it a like, share it with your friends. It really helps the channel out because, well, lately YouTube has been screwing around with the views and stuff. So it's been very, very difficult to stay motivated in recent times. So yeah, any view helps. And of course, if you've got any comments or questions, please pop them down in the comments below. And until next time then, stay safe everybody. I'll see you all soon. Cheers!